All right, this is section 7.5, and we're going to just do a few examples with some basic operations using matrices. We're going to look at adding, subtracting, multiplying by a scalar, and multiplication of matrices. First of all, before we begin, just to let you know what a matrix is a way of displaying information or a way of displaying numbers. And these are your rows going across, and these are your columns going down. And so if you have a matrix that has, let's say, 4 total elements, then this would be row 1, column 1. This would be row 1, column 2. This would be row 2, column 1. And row 2, column 2. You have the 4 elements, so if you have 2 rows by 2 columns, we call that a 2 by 2 matrix, and we always do the rows by the columns. All right, so that's the size of the matrix. We use the dimensions in order to compare matrices. First thing that we're going to do is we're going to add matrices. Now, in order to add matrices, you have to have the same size. It has to be, so this is a 2 by 2. And this one is also a 2 by 2, so they have to be the same in order to add. All you need to do is add corresponding parts. -1 plus 1 is 0, 2 plus 3 is 5, 0 plus -1 is -1, and 1 plus 2 is 3, and that's all you need to do in order to add matrices. All right, let's look at another one. I'm going to change up the size of the matrix. So if I want to add these matrices together, here, see, this is a 2 by 3, that's the rows by column, so 2 by 3, and this is a 2 by 2. So they're not the same. So this is, not possible. All right, the next thing that we're going to look at is how do you represent with scalar multiplication. Scalar multiplication, you just have the scalar, the constant 3 on the outside of your matrix. And to multiply here by a scalar, it's like the distributive property. And you're going to multiply all 4 elements of the matrix by that 3. So -3, 24, 18, and 6. And so that would be your result of the product. All right, here's what we've got. Next is to show how to do matrix multiplication, so taking a matrix and multiplying it by another. First thing that you need to do is, I'm going to go ahead and write the matrices next to each other. And when you multiply matrices, it does matter the order that you multiply, unlike multiplying just numbers together. So what you need to do is you take your first row. You take your first row of the first matrix and you match it up with the first column of the second matrix. And this would be, you match the elements together. So you're going to do -1 times -3. Then you're going to add to it the second element, 3 times -4. And this would equal 3 plus -12, which is -9. Now what that gives you is the answer of the first row, first column, so -9. We're going to repeat the steps for each row and column. So now I go row 1 and then now column 2. Row 1, column 2 would be -1, and you pair that -1 with the 2 times 2. Then you're going to add to that 3 times the 1. So that's -2 plus 3, which equals 1. Now that is the row 1, column 2, since those are the rows and columns that we matched together. We're going to repeat this process. Now on the next step, we're going to use row 2, and we're going to do row 2, and then you turn it sideways and you match it with row 1. So that would be 4 times -3, and match up the second component, -2, with the second component of -4. Add these together, you got -12 plus 8, which is -4. So this, since this is row 2 and this is column 1, then I place that product, that portion of it, here in row 2, column 1, so -4. Let's go ahead and look at the next. So row 2 with column 2. You do 4 times the 2 plus second component, -2 times the 1. So that's 8 plus -2, which is 6. And you see we're going to do this one more time, and the last time is going to be with the third row, first column. So you multiply 5 and -3, that's -15 plus -4. -15 plus -4 is -19. Then we do it again. Row 5, 1 with column 2, 1. So that's 10 plus 1, 11. And so this right here is the result of your product of the two matrices A times B. All right, so something to keep in mind is when we are multiplying matrices, the size of the matrix is going to matter, just as it did with addition. Here's what we need to know. If I am taking this matrix A and multiplying it by matrix B, matrix A is -2, 1, 1, -3, 1, 4, multiplying it by matrix B, which is a 3 by 4. Here's what we need to look at. So we're going to take row 1 and we're going to multiply it by the column. But when I go to match up corresponding parts, I would match up the -2 with the -2. I would match up the 1 with the 0. But I don't have a third element to match up with the 2. So this indicates the sizes aren't matching up. So we can't multiply. This is not defined or not possible. Here's how you're going to determine if it's possible to multiply. If you have a 2 by 2 matrix and you're going to multiply it by another matrix, let's say a 2 by 4, these middle terms here, they have to be equal to each other in order to multiply. So if you're multiplying a 2 by 3 by a 2 by 4, these are not the same. You're not able to multiply them. So they have to be the same here in order to multiply those together. All right, let's take a look at a couple application problems. A company offers 3 types of healthcare plans with 2 levels of coverage to its employees. The current annual costs for these plans are represented by matrix A. If the annual costs are expected to increase by 4% next year, what will the annual costs for each plan be? The first thing that we want to do is let's just go ahead and label some things here. Make this plan A. We'll make the next column plan B. See, it said there was 3 plans, and then plan C. And then each row here, let's say that it's level 1 and a level 2. They said there's 2 different levels for each of the 3 plans. If this is the current year's and I need to go ahead and find then the next year, which is a 4% increase, then here's what we have to do. Here's my matrix again. Each of the 3 plans, each of the levels. So this is the current year. If I were to multiply this by 4% and then add it back onto the original, I'm really needing to multiply by 1.04. What this will do, the 1.04, is it's going to go ahead and add the increase on to the original. So it's just a scalar multiplication. So we're going to multiply those together. And we still need to label our matrices. And when you multiply 694 times 1.04, you get 721.76. And then again, on that second position, multiply 469.04. And the last position is 508.56. All right, in the row 2, 1.04 times 1725 is 1794. And 1234.48. And finally 1297.92. So this is the results of our problem. All right, one more problem left here. Softball team expenses, example 7. 2 softball teams submit equipment lists to their sponsors as shown in the table below. Each bat costs $80, each ball costs $6, and each glove costs $60. Use the matrix to find the total cost of equipment for each team. We basically need to take, in this case here, we need to take the cost of the equipment and multiply it by the inventory. Now, since the column here, let's say W is for women, the column here represents each part of the equipment. And so if I'm multiplying then the cost, I need to have the cost listed this way. The cost of the equipment, so for bats, because I need to match up the parts, the bats would be $80, the balls are $6, and gloves are $60. So that would be multiplied by the matrix of inventory, which is 10, 45, 15, 15, 38, and 17. And the question is, use the matrices to find the total cost of equipment for each team. Total cost for each team would be individual costs. So let's go ahead and multiply these together. You are going to take row 1 times the column and all the corresponding parts. So 80 times 10, 6 times 45, and 60 times 15. And we're going to add them together. So 80 times 10 plus 6 times 45 plus 60 times 15. And when you multiply that together, you get 2,130. So this is for women, and this is cost. All right, on the next, we're going to go again. So cost times the men's team. So it's 80 times 15 plus 6 times 38 plus 60 times 17. And that will give you a total cost of 2,448. That's for the men. All right, that's it for the operations on matrices, and here is your assignment.